Our lesson today is about analyzing data using measures of center. It's called In the Middle. It's lesson 16.1. In this lesson, we will review the meaning of mean, median, and mode, which I know that many of you have dealt with in the past, especially in 5th grade math. And we'll also calculate and interpret the mean, the median, and the mode for a set of data. So key terms: measure of center, mode, median, balance point, and mean. So the good news with this lesson is that it's going to be a lot of review for a lot of you. So let's get right into it. So what trait do ballerinas, gymnasts, running backs, and tightrope walkers all have in common? Each needs to have balance to be successful. Maintaining a balance in sports is just one area where balance is important. Many companies also strive for their employees to have balance between work and everyday life. Even Franklin Public Schools has a wellness program for its employees that the teachers can be a part of, which is pretty cool. So what type of balances do you have, and are they related to school or leisure? What do you do to center yourself, to relax a little bit and make sure your life is balanced, because that is important. So take a moment, think about that. When you're done reflecting, unpause the video. Problem 1 says, put me in, coach. We've all heard that phrase before, probably heard that or thought that at a time ourselves. So let's see what the problem is about. It says, when you analyze a set of data, you often want to describe it numerically. One way to numerically describe a data set is to use a measure of center. A measure of center tells you how the data values are clustered, or where the center of a graph of the data is located. And notice that is a key term. So I circled measure of center, the key term, and I underlined the definition. Make sure I mark my text. Make sure you do the same. There are 3 ways to describe how a data set is centered: the mean, the median, and the mode. The mode is a data value or values that occur most frequently in a set of data. So again, I'm going to mark my text. The median is the middle number in a data set when the values are placed in order from least to greatest. So when a data set has an odd number of data values in this set, you can determine which number is exactly in the middle of the data set. If there's an even number of data values, then the median is calculated by adding the 2 middle numbers and dividing by 2. So here's a couple of instances where there's differences in how to find the median. So that'll be important for us to go back to. I'm going to put a little star by this. So we make sure we go back to it if we have trouble thinking about how to find the median in different situations. So let's take a look at problem number 1. The Olive Street Middle School girls basketball team has a chance to be champions. Coach Harris must determine which of the following 3 players should get more playing time in the championship game. In the past 6 games, Josephine scored 12, 12, 6, 26, 4, and 12 points. In the past six games, Shelley scored 3, 2, 8, 17, 10, and 20 points. In the past 6 games, Janice scored 15, 12, 13, 10, 8, and 14 points. As a basketball coach myself, I know that it's really important to know who is playing well at a different time, so you always have that hot hand in the game. So obviously a question for Coach Harris as well. Problem A says, determine the mode for the number of points scored by each player, and determine the median number of points scored by each player is letter B. So go ahead and do those right now. When you're done, unpause the video. For problem A, the mode for the number of points scored by each player, the mode for Josephine is 12 points, because 12 occurs 3 times in that data set. Whereas for Shelley and Shanice, there is no mode, because all the numerical values only occur once. And then for letter B, the median for Josephine, here's one way that you could organize your data set. So we have 4, 6, 12, 12, 12, 26. Notice how it's ordered from least to greatest, so that you have those values in order, and you can find the middle. So there's 1, 2, 3, 4, 5, 6 numbers in that data set. You have to take half of the two middle numbers, in this case half of 12, and half of 12 and 12 is 12, so we don't really have to do anything there. But for Shelley it's a little different. You can see that 8 and 10 are the two middle numbers, and so then 8 plus 10, adding those two numbers together, is 18, and divided by 2 equals 9, and that allows us to find the middle of the two middle numbers in that data set. And then for Shanice, the two middle numbers are 12 and 13. So if you add the two middle numbers together and divide by 2, it's 12 and a half. And that makes sense. 12 and a half is in between 12 and 13. Problem C and number 2 both give you a chance to practice your justification skills a little bit. Problem C says, which of these two measures of center would be better for Coach Harris to use in making your decision? Explain your reasoning. Make sure you are given a clear justification. Don't just explain, justify how you know. Number 2 says, for the data set 5, 6, 10, 4, and 9, Omar says that the median is 10. Do you agree or disagree? Explain how you determined your answer. If you do not agree with Omar, what do you think the median of the data set is? So there's a lot of different things that you have to do for problem 2. If you need to do a do what to recognize all the different things you have to do. When you're done, unpause the video. Since you're looking for a player with the hottest hand, you want the best player on the floor, the median would be the better measure to use. In this case, if you're using the mode, Chanice would have been eliminated, but she actually has the greatest median, and you'd want that person scoring the most amount of points, typically to be on the floor. For problem 2, I would disagree with Lamar. Lamar forgot to put the numbers in order before calculating the median. So he had it in the middle, but the order of the numbers were not in least to greatest order. So the median should have been 6. Previously we learned about two measures of center, the median and the mode. There's a third measure of center that can describe the values in a data set. The measure of center is based upon establishing a balancing point. Analyze the two stacks of cubes. So the white one, the blue one. If you were to create two equal stacks of cubes, you would subtract 2 cubes from the greater stack and add the 2 cubes to the lesser stack. In doing so, you have created 2 stacks of equivalent amounts. So if you notice here, the first stack, the white stack, has only 2 blocks, whereas the blue stack has 6 blocks. If you cut 2 off of the blue stack and put it on the white stack, you would even the 2 stacks out. So if we took a look at problem 3, it says analyze each stack of cubes shown. Make each stack have the same number of cubes, then describe what operations you performed for each stack to have the same number of cubes. Finally, sketch your model of all the stacks with an equal number of cubes. Don't forget to draw an equivalent line to show the stacks have equal cubes. So looking at an example here, for letter A we have 2, 3, 5, and 6. So we have 4 different size cubes, or stacks of cubes. So it says to create 4 equal or equivalent stack of cubes, and just subtract 2 cubes from the stack of 6 cubes and add them to the first stack. Then I had to subtract 1 cube from the stack of 5 cubes and add to the second stack. This results in all stacks having 4 cubes. Okay. So again, this one has 6, the biggest one. This one only has 2. This one has 3. This one has 5. In order to make them all have 4, 2 would come off the top, or the biggest stack, the one on the right, the far right, to go on the smallest stack, and then the 2 middle stacks, the stack with 5, you'd take off 1 and put it on the other stack. So right now, do the same thing with letter B. There's a data set with 2, 3, 5, and 10. You need to rearrange the stacks so they all have an equal number in each stack. When you are finished, and you're finished with your explanation of how to do that, make sure you're making it clear to your readers how you did what you did and how you rearranged each stack. When you're finished with all that, then you can unpause the video. To create 4 equivalent stacks of cubes, you could subtract 3 cubes from the stack of 10 cubes, add them to the first stack, then subtract 2 cubes from the remaining 7 cubes in the last stack, and add those cubes to the second stack. This results in all stacks having 5 cubes. Then answer number 4 as well. What happened to the equivalent stacks when the stack of 6 cubes in question 3 was changed to a stack of 10 cubes in question 3 part B. When you're finished, unpause the video. Another way to find balance points in sets of data is to use a number line. So we can use a number line to help us create equivalent values. It says, notice each x in the box. These x's represent 2 and 6 on the number line. So 2 was moved to the right from 2 to 4. To maintain balance, you must move 6 to the left from 6 to 4. So then the balance point is 4. Again, if we look at this first graph, we look at where the middle is between 2 and 6, it's right here, because that's 2 away from the numerical value of 2, and it's 2 away from the numerical value of 6. So that would be right in the middle. That is the balance point. When you're attempting to create a balance on a number line, you must move data values on each side of a side in a balanced manner. In other words, if you move a value to the right of a certain value, then you must move a value to the left of a certain value. Kind of like what we've talked about with fractions. If you're trying to make an equivalent fraction, whatever you do to the numerator, you have to do the denominator. Just like when we're using algebraic expressions, how do we undo something? We need to make sure that we keep things balanced when we're undoing something, so that the equation remains balanced. This is kind of the same thing. So you can move a data value to the left and right as much as you like, as long as you do the inverse to another data value in a set of data. So number 1 says, what do you think the triangle represents? This is where I'm going to leave you for today. I'd like you to work through the next couple of pages on balance points, and you'll get into talking about the balance point being defined as a mathematical term as the mean, which I know all of you have heard before. And that'll take you through page 1078. And then there's just 2 problems on number 4, calculating the mean on 1079. That's where you're going to stop for today. So you're going to stop on 1079 after you complete number 4. Alright, thanks for watching. We'll see you all again soon.